All right, let's talk about one of the biggest headaches in the entire crypto space, scalability. In this explainer, we're going to break down a really cool solution called sharding, and then look at a brand new innovation that makes it way, way better. So let's just dive right in.
You've been there, right? You're trying to make a transaction and you're just stuck, waiting, watching those fees creep higher and higher. Well, you've just experienced the blockchain scalability problem firsthand. The more popular a network gets, the more it gets clogged up, and that slowdown is a huge barrier to this tech really taking off.
So here's our game plan. First, we'll get into why this digital traffic jam even happens. Then we'll look at how sharding promises to clear the roads. After that, we'll check out a much smarter way to do it that's getting some amazing results. And we'll wrap up by looking at the hard numbers and, of course, how it all stays secure. Okay, so first up, what's the root cause here? Why do these super popular networks grind to a halt? Well, it all comes down to this fundamental puzzle that developers are always trying to solve, and it's famously known as the blockchain trilemma.
Yeah, it's a classic case of being a victim of your own success. The more people who use a blockchain, the more data it needs to crunch. And every single computer on the network, what we call a node, has to check and approve all of that data. You can see how that creates a massive bottleneck. That delay, that's what we call latency.
And this quote right here, it nails the problem. Developers are in this constant balancing act between three things: keeping it decentralized so no one's in charge, making it scalable so it can handle tons of traffic, and making sure it's super secure. The issue is, you can't have it all. When you crank up one of those dials, another one usually has to go down. That's the trilemma, and it is a developer's nightmare. So, how do you fix this mess? Well, what if, and this is the big idea, what if you didn't force every computer to do all the work all the time? This is where a really clever concept called sharding comes into play. It's a direct shot at solving that scalability problem without messing up the other two. So what is sharding exactly? The simplest way to think about it is divide and conquer. It takes the one massive blockchain database and splits it into smaller, way more manageable little pieces. And each one of those pieces is called a shard. Each shard handles its own set of transactions, all at the same time. The highway analogy is probably the best way to picture this. A typical blockchain is like a highway, but with only one lane. Imagine all the cars in the world trying to use that single lane. Total gridlock, right? Well, sharding is like building a bunch of new, parallel lanes right next to it. Now, traffic can flow through all those lanes at once, and way, way more transactions can get through. Okay, so adding more lanes is a great start. But what if I told you there is an even smarter way to manage the traffic in those new lanes? Well, researchers behind a protocol called Manifoldchain have figured out a brilliant new twist on this idea. This chart just makes it so clear. The old way, uniform sharding, is on the left. It's kind of like just randomly assigning cars to lanes. You get a Ferrari stuck behind a slow-moving truck, and the whole lane grinds to a halt. It's only as fast as its slowest part. But look to the right. The smart way groups miners by their internet speed. It's like creating a dedicated express lane just for the Ferraris. The whole system just flows so much better. So that sounds fantastic in theory, but does it actually hold up in the real world? Well, the researchers put it to the test to see just how big of a difference this makes. And honestly, the results are pretty staggering. Get this. In those express lanes we were just talking about, the shards with the fastest miners, they saw a 5 times increase in throughput. That means they were processing 5 times more transactions than they could with a standard setup. That is a massive jump. And that's not even the whole story. It wasn't just the fast lanes that got a boost. When you look at the average across the entire network, transaction capacity tripled. So the whole highway is moving faster, not just one lane. Now, you don't have to be a data scientist to see what's happening on this chart. The orange lines, that's Manifoldchain, and you can see them just shooting upwards, confirming tens of thousands of transactions. And the blue lines, that's the competition, staying pretty flat. The visual proof is right there. This system just works. So what's the real secret sauce here? Well, this table sums it up perfectly. What really makes Manifoldchain stand out is that it actually uses the extra resources you give it. See, other systems don't always get faster just because their miners have faster internet. But this one, it's designed to take all that extra horsepower and turn it directly into more speed for everyone. Okay, so it's fast. That's awesome. But is it secure? Let's not forget that trilemma. Speed is great, but it can't come at the cost of safety.
And splitting up the network like this does open the door to a potential new risk we have to talk about. The big worry is something called a shard takeover. Think of it like this. It's a lot easier to bully a small group of people than a massive crowd, right? Well, because each shard has fewer miners, it's theoretically easier for a bad actor to gain control of just one of them. And if they did, they could start approving fake transactions and really mess things up for that piece of the blockchain. But of course, the people who designed the system thought of that. They built in a clever two-part defense system. First, you've got fraud proofs. This is basically a network-wide alarm. If one honest miner spots something shady, they can alert everybody instantly to shut it down. And second, this really cool thing called coded Merkle trees. It's a super efficient way for miners to check up on their neighbors and other shards to make sure everything's okay without having to download tons of data. It keeps the whole network secure and fast. So here's the big takeaway. Sharding is a seriously powerful fix for blockchain's traffic jams, and these new, smarter approaches are making it a game changer. When you can get this much faster without giving up security, you start to unlock the real potential of this technology for things like global finance, high-speed gaming, and probably a million other things we haven't even dreamed of yet. It really makes you wonder, doesn't it?